And show. Awesome. So we are live. Hi
Hello,
everyone.
hello.
Hi everyone. I'm Laksh. I'm the organizer of Flutter Nagpur and a software engineer. Today we are in the second session of Flutter Production Nagpur's virtual edition, and we have an amazing personality, Shreyas Joshi. He's a software engineer and a digital designer. He'll be talking about the hidden frameworks behind every reliable app. Moreover, very core engineering stuff and not just development UI of Flutter, rather the core sides of it. Insights news. I have worked with Shreyas for about 6 months and I gained a lot of knowledge from him. I'm pretty sure you will get a hang of it in this 1.5 hour session. So stay tuned and listen to him carefully. Shreyas, all yours.
Hello, hi everyone. Today I'm going to be presenting a talk that I was supposed to be presenting in person, but due to unforeseen circumstances, I could not attend the event that was held last week. But today, here I am presenting the same talk. We will be talking about hidden frameworks that make an app reliable. So, let's first begin with an intro. I've been developing production grade Flutter applications for the past 5 years. I will be talking about the hidden frameworks behind every reliable app that I have made till date. I want you to take away from this session what I have learned in the past 5 years. These were incremental learnings that I'm squeezing in one single session today. So, at the end of the session, I'm hoping you learn to avoid common pitfalls in versioning, rollouts, and security. You'll be able to use tools like feature flagging and crash logs to serve different types of features and functionalities to your user base. You would also learn to leverage native capabilities and server side logic to create seamless app experiences. So, a little bit about me, I'm a computer science graduate. I have been born and brought up in Pune, Maharashtra. I worked at a healthcare startup for 4 years, and I've also worked directly with different businesses to help them launch different products. So that's been my journey throughout 5 years. I actually started as a digital designer doing content and graphics. Then, with my engineering degree, I moved on to UI UX. And throughout the last 5 years, I've been just delivering applications and software to millions of users. So my expertise lies in software engineering and digital design. That is something I spoke about, and I have made different kind of mobile applications and websites. And in digital design space, I've worked with clients who have needed branding help. I've done packaging, physical packaging for stuff, and UI design is something I've had to do on my job for the past 4 years, 5 years collectively. So this is my career trajectory. I worked at iMums, the startup I mentioned, for 4 years. I was hired as the first person over there. We have served over 2 lakh mothers. We have we have a digital platform and application that helps users connect with different healthcare professionals needed to guide them throughout their pregnancy. After working at iMums, I was also entrepreneurial, and I have partaken in Studio Kabir, a fashion and lifestyle brand. We launched a website. It's not in Flutter, but it's still something that involves technology. And everything I learned at iMums was something that I translated into the other businesses as well. In the last 6 months, I've been working with another business called Mentoria in Mumbai. We are developing another application that connects users with working professionals across different domains. I have been given the responsibility to develop the entire app end to end, and we are about to launch in the coming week. So I hope any one of you who's watching this would be interested in downloading the app and giving us feedback as well. So, moving on today's agenda, I have already given you an intro. I will set the stage and let you know what reliability actually is, how you would define it. Then I will give you a bigger picture of all of the frameworks that I have in mind. Then we'll unpack the essentials one by one while I share my experience throughout the presentation. The main takeaways will come later, and if we have time, I would be happy to answer any question and answers that we can entertain. So, moving on. Every promise you keep, you increase your chances of being reliable. This is true for personal or professional commitments. Every time you decide to do something and you are able to do it, you become more reliable. It's only in the absence of reliability is it pointed out or is it noticeable to someone. So, reliability is something you have to keep up every day. You can't drop the ball on reliability. There's something I would like to quote. This is an image of the Mars Climate Orbiter. This image is from 1998. This was in November when this was on Earth, and in December on the right hand side, what you see on left was sent to Mars. So NASA launched this on December 11th, and this Mars Surveyor mission, it was supposed to check out all of the Martian climate, Martian atmosphere, and surface changes and communicate it back to Earth. Next year in October, this is the headline that you would have read in LA Times. The Mars probe was lost due to a simple math error. This was very shocking. It cost NASA $125 million then, and the simple mistake being conversion units, metric and SI system. So that's something very dreadful and harrowing, but this is the cost of having an unreliable system. And I just wanted to begin with a strong example. I hope none of you ever are in a situation like this, but remembering this, what happened is there was a planned trajectory, and due to the error, it was too close to Mars and it lost contact and crashed. So this cost NASA a lot of money, and this is what happens in real world. Businesses lose money because technology is not reliable. The cost of unreliable apps, in our case, would come in terms of crashes, user reviews, people uninstalling our applications. I have some data from personal dashboards as well as some research I've done online. So there's a 62% uninstall rate because users face some kind of a crash. This is always going to negatively affect your application, and it's also going to have reliability issues. People are going to be very quick to jump to the Play Store, App Store, and write a review. Something's not working, something's failing. I don't like what's happening in this application. So this is something we as developers need to ensure we avoid, because this is not only the product's responsibility. The tech drives the product, is my belief. So this comes driven from the tech side. Slow loading and downloading times are a significant factor, as everyone would know. For 25%, almost 25 to 30% of users abandoning your application. 75% of mobile applications fail due to security tests. A friend of mine works in security, network security, and he performs different kinds of assessments and reviews with different organizations. I got a very shocking metric from him where he said major organizations do not have the necessary security protocols in place to keep the data safe, the data they may be collecting for the users or the data they might be generating. That is very shocking. So, this comes from outdated systems relying on outdated technology, not ensuring that we have enough resources to allocate our time to have a reliable foundation. So, what I would like to say is great apps don't just happen. Like a sturdy house, they need a strong foundation. Imagine opening your favorite app and it crashes. It's frustrating, and you don't want to be the developer who makes something like that. In fact, it costs a lot to actually be in production and realize these mistakes when you have launched something. You launch something, it does not work out, and to actually get it to work, you end up spending a lot more. So, a great foundation is something you really need to invest in. I would move on to telling you about the strong foundation elements. The first three pillars that form our foundation would be code versioning, controlled rollouts, and security protocols. Then we move on to crash logs, debugging tools, and feature flags. We have server side logic, platform specific requirements, and native capabilities that follow. So these are the frameworks that I'm going to be talking about. These all serve as a tool to introduce reliability in your code base in the products that you're creating. Versioning is one of the most critical yet underestimated and underrated aspects of app development. Every app evolves over time, and managing updates can be tricky. You have to release new features, you have to incorporate new versions of the frameworks that you're using. You have to release new versions to fix the bugs that you may have introduced or which may have been introduced due to some framework changes in the world. What happens when something breaks? You just make a new version and distribute it. So, a good versioning strategy is going to ensure that your code is separated out into different builds and it's distributed to your users. And internally, when you're developing code, it is also important in terms of identifying different versions of your code. It's not only the external facing version. So, like I was saying, versioning is going to impact both your own code base and the external integrations. So, your own code base has different versions that you release to the public. Also, while developing, it has different versions that are under development under different teams at the same time. And there are also external integrations and frameworks that you rely on that go through different phases of changes during the time phase they are out there in the public. There might be some bugs, there might be some OS level upgrades that are present. So part one of versioning is versioning your own code. When is it relevant? When you have major quarterly maintenance and framework upgrades. So a big part of launching tech in production is using the stable version of Flutter. Every time we are releasing an application, we are using the stable version of Flutter. Now, as we all know, Flutter is releasing different versions on a quarterly basis. And at the same time, there are different integrations that we use that also have quarterly lifecycle policies. To quote, there's an integration we use, Zoom video calling. What they do is on on a quarterly basis, after every 3 months, the integration that you're using, the dependency, it is going to become outdated. So it becomes your job as the developer to ensure that the version that's in your user's hands is going to be the latest app version with the latest dependencies. So this is where quarterly updates come into picture. There's no new features you want to develop. It's just operational work that you are doing. Keeping how it's not, it falls under housekeeping technically. I would not like to call it that way, but yes, it is an important part that needs to be assigned during your quarterly, monthly, or year-long technical roadmap that you would have either in your own organization or your own personal project that you're talking about. And then there's weekly feature launches or monthly feature launches that you would do. after releasing a product, you're gonna have user feedback. Your users are gonna demand something. You, as a business or an individual, are going to realize there are different things that you need to introduce and improve inside your application. That is when you are adding new features and functionalities. So that is when you would be versioning your code. The challenges that you would face during versioning and releasing updates is ensuring you have backwards compatibility with older versions. Imagine changing some database structure and changing the data that lives in your server. You're changing it for the new app version, but people who are still using that application may get an error on their devices. So that is something you need to take care of when you're introducing new features. Old app versions that are still going to be live do not break. So as you start developing and releasing new updates to your application, there's always going to be one, two, three, and 10 different versions that are always live in people's hands. And you also need to avoid regression bugs when you're rolling out these new features. When you're versioning your system, there could be some changes that get repeated or undone, and you need to ensure they don't keep on coming back, and that is what regression means. Now, the best practices you need to follow when it comes to versioning is semantic versioning. Every time you make a change, there are some rules that you need to follow when you change your pub spec file. And that is something you need to do every time when you're creating new builds, either internally or when you're releasing. So you please feel free to look up semantic versioning if you're not explicitly aware of it, but you would have come across things. So the first number that you see is the major version, the middle number is minor, and any bug fixes and patches are added in the last part of your version number. And this is like a universal convention for people to understand. When you see a change in the version number of a particular dependency or a framework, how seriously do you need to treat it is what this will signal. If it's going to have a breaking change or it's just going to be a version bump and you need to forget it. Then, when you're actually developing new software or maintaining libraries for someone or packages, you need to maintain a detailed change log of whatever's happened. What needs to ideally happen is you could auto generate it from all of your commit messages. I hope everyone's using Git. So, all of the commit messages that you make when you're editing your files, they ideally will be condensed into a detailed change log for you. You can add some layer of analysis to it. So every time there's a new version that either gets published or packaged or updated somewhere, people know what's changed. To give you an idea, every time if you go to any package on pub.dev, there's a change log section that you would see, and they will tell you what's changed in this version, if there was a breaking change or if they added a new functionality or anything. So maintaining that change log is something that you will have to consider and take care of. You also need to automate your testing pipelines to detect compatibility issues early on. This usually comes towards the end part. You develop all of your code and then you go on to test it. So it's better to start testing it out early on and have automated pipelines to get those tested and detect issues. So this was about part one. We move on to part two, which is managing versions for your integrations. This is in the form of dependency management. Third-party libraries often stop updating themselves, leaving you with unsupported code. So whenever you're making an application, your pub spec is going to have all dependencies. Working at IMAMS, there's this particular incident I'd like to share with everyone. We were going through this null safety phase in Dart, and we were moving from non-null safe to null safe code. We migrated everything. We, as in everyone in the Flutter ecosystem, was doing it, and we deferred it for 3 months to 6 months because there was limited support, and it was a big change that could have affected production. So when the time came, we updated a few dependencies, and there were a few integrations that did not support null safety, and their package maintainers had already abandoned those packages. So that was something that we had to face. That's a real world example. What we had to do, you'd see in the second part I've mentioned over here. In this particular case, we went to the package, we found out its GitHub repository, we forked it ourselves from our organization. We applied null safety migration ourselves to an integration that was there. And then in our particular application, we referenced that particular Git repository instead of the pub dev version. So these are the things you will have to go through when you're in production and you have actually committed to something and you've already launched it. When there's no going back, you have to find a way to not go back and keep on proceeding. Now, when you're updating your versions, this was one thing that could come up. The other most common thing that comes up is conflicting versions between dependencies and them leading to build errors and runtime failures, or most of the time you're blocked at the compile phase itself. You won't be able to generate an executable. So at this stage, you would want to figure out a strategy of how you actively manage dependencies and their conflicts. And you need to figure out a strategy, move one by one, find the sweet spot where all of the dependencies match, make use of your log files properly. So the best practices, I would say, to manage your versions and integrations is to audit and monitor your dependencies regularly. Keep an eye on how the framework is evolving. A part of being a great developer is what I tell everyone who works with me is staying up to date with what's happening in your industry. The fact that you're using Flutter would mean you have to keep up with what's happening in Flutter on a weekly basis, on a monthly basis. So every time there's an upgrade, I would urge all of you to stay in the loop, figure out how that can be useful to your application. If you've been in those problems before and those problems have been solved, and if those problems have not been solved, Flutter has a wonderful community where you can create some issues, report them yourself. And if you've seen Taha's talk yesterday, it was wonderful how they showed us how to contribute to the Flutter ecosystem. So version management is something he has touched yesterday upon, and it was a great talk. Shout out to him. Do check out on the YouTube channel, I would suggest. Now, keep an eye on community activity for libraries you depend on, fork them early, understand the code. If possible, move away from using third party integrations. Why would you want a loader animation or some minor code as a dependency? If it's a few lines of code, I would suggest you go look at the code, appreciate the person who developed it, but have your own version of it in your code base just so that it's future proof. If that person decides to abandon it, you don't really have to worry. The code is in your hands and you're the person who can quickly make changes to it instead of relying on someone else. Next, we are going to move to controlled rollouts. Controlled rollouts, आपने you've created a new application. Let's consider this scenario. You launch version 1 of your application and it's going well, and now you want to develop a new application, a new feature update on top of it. You're pumped. You as a developer have written all of your code. You've created a new build. You've just used your versioning control system to create a new build with a new version number 1.0.1, because probably it fixes some bugs through semantic versioning. That's something you'll be communicating with your users. If it was 2.0.0, it was a major upgrade, correct? So now you have this new build and you want to roll it out. What do? Do you push it to all of your 100% users? No. That's where controlled rollouts are coming into picture. These will reduce the risk during your deployments, and it's a step to to ensure your new features and updates are going to work as intended. These allow you to move gradually rather than going all in and hoping for the best. A very fun example I would suggest you to imagine is every morning when you're taking a hot shower, you turn the tap on, the water starts sprinkling. Do you directly go under the shower? Maybe if you're a cold shower person, I am not. So what do? I wait for a minute, then I put my hand under the water to feel the temperature. And then I go in the shower when I know the temperature is to my liking. This is a way of controlled rollout, exposing myself, the audience, to something that's being launched, the water, when it's the right time for the audience to appreciate it. So, what, how does it relate to your applications? You have a new checkout system and you just don't want to launch it right away. You would want to launch it to a few set of people, ensure it works, and then you launch it to everyone. So how does it work? It works as phased rollouts. You begin with an internal testing phase where the feature is tested in your controlled environments. Only the developers or the internal team is who get access to this feature and functionality, and regular users, the other users, production users, as we call them, they are not exposed to this new feature. Now once everything is working in your internal app, usually you would have an internal testing distribution system, and we have a separate production distribution system for all of our production environment. So you have it tested internally. Now you move to production, but you don't launch to 100%. You only roll out to 10% users. You monitor their performance. You either validate your hypothesis if there's some change for which you've specifically created the update. If there are any critical issues that you have introduced, they can be caught. What this does is it doesn't put all of your eggs in a single basket. Another analogy that you could use, so if something is gonna go wrong, it's not gonna go wrong with everyone. It's gonna go wrong only with 10% of users. So if the hot water it was burning, I would not get burnt, only my fingers would. It's 10% versus 100%. So that's the strategy you need to apply when you're releasing new app versions to your users. And once you're extremely sure, once you've monitored all of the things that everything's correct, there's no crashes happening, it's validating the hypothesis. New type of checkout button is going to increase sales. Yes, it is increasing sales. Okay, then let's roll it out to 100% audience. If it's not, let's not do that. So you get to control how your app behaves. If something were to go wrong, you have the switch in your hand to stop it. The advantages are bugs and critical failures are avoided. We have been in situations where we were testing something, 2 days in, we realize in the user journey after 2 days, something is not going wrong. Something is not going right. It's throwing an error and there's a gray screen that we see. And the only way to fix it was to release a new app version, but we were already on the Play Store. Now, we had only released it to 100 users, out of which 50% of users had interacted with the actual feature that was buggy. So we added a patch, released a new version. We just halted what was out. There's a new version. Everyone who downloaded the previous version, affected version, only 50 people, they upgrade to a bug-free version. And people who are not in the test, they by default are going to upgrade to a bug-free version of your latest feature that you want to release. You are also able to validate your hypothesis. You test your new features in production, gather user feedback, you monitor analytics, whatever you decided. For the example that we were taking earlier on, there's a new type of button or a new type of checkout flow that's supposed to increase sales. These are discussions that happened in a room between a team. This application, when it's out in the hands of the users, is that what really is happening? Did we spend a month creating a feature, and are we going to spend another month out in production with it in users' hand when it's failed the very thing that we are trying to prove? Then it's of no use. We've wasted 2 months of business time, resources, valuable users' time. So this is where phased rollouts and hypothesis validation come into picture. You have a fallback strategy and you have your test strategy. You test between the two. Something works out, something works out, something doesn't. You just go back to your fallback strategy and release something that's already working. There's operational flexibility, like I mentioned, rollback or halt your rollout. If something doesn't work, just make it disappear, because it's not out for 100% audience. You get the liberty to do that. What you need to know is this is a feature built into the Play Store and the App Store. When you're submitting an update, you're going to have an option where you get to select how it is released to your to your user base. Every time you upload a new update, it first needs to get approved by the store. Google or Apple is going to go through that app update. It's going to see your release notes and verify that nothing has changed, no malicious activity was conducted between the two versions that you are talking about. And after that is approved, what do you do? Do you release it to 100% of your audience? Do you release it to a percentage of your audience? This is what the platform itself is going to give you. So, as developers, as product owners, we need to leverage this functionality. We need to get into the mindset of releasing products in controlled ways such that it helps us draw critical insights for the business and save valuable time and money. Rollouts can also happen geographically, by percentage, by device. You only roll to Android, you only roll out to iOS. And that's about it. That's how controlled rollouts work. Now we move on to security. It is just it just isn't a feature as such. It's a commitment that you have towards your users. It's a silent guardian of your application, of your technology, of your users' data, and your reputation. Everything is at risk if you do not have security measures in place. In today's world, where data breaches and cyber attacks make headlines, you have to ensure you have robust security protocols in place such that your application, your technology, whatever you're putting out in the world, is reliable. It is not susceptible. When people are trusting you, your application, as a business, as a developer, you need to actually live up to the trust and the words that you're putting out. When you actually want to release something on the Play Store, the App Store, there is a privacy policy, a security policy. There is a questionnaire that you have to answer every time you are releasing something. There may be questions about some data changes that you might have done. And it is our responsibility as developers to keep that layer of security always in check. It always needs to be present. Now, the key security practices that I would like to touch upon is database rules and authentication, and the second part would be signing certificates. Now, database rules and authentication, as it suggests, access to data in your application needs to be secure. As a user of a social media application, I should not be able to access data saved by another user. Imagine you, as an Instagram user who's saved a different number of posts from your timeline. can go to your application and somehow hack your way into someone else's saved videos or someone else's DMs. Those would be disastrous things to witness. So these are a part of database security, database rules, where you need to have granular access to data based on user authentication, who's requesting the data, where is it being shown. You also need to comply with different guidelines if you're developing a healthcare medical application. You need to comply with certain guidelines, HIPAA guidelines. In general, if you're operating or distributing in the European Union, you have to comply with the GDPR. There are different other operating system level enforcements that we see, where clearing your data when you delete your account needs to be possible, which is enforced at an operating system level. So it's not a particular vendor that you're choosing in your application's integration, it's directly the platform's requirement of how you are handling the data in a secure and safe way. So with Firestore, the most popular choice with Flutter developers is Firestore and its suite of services. So in Firebase and its suite of services, where Firestore is a NoSQL database for those of you who may not have used it. It basically lets you create collections. You have documents inside it. So there's a user's collection, there's different user documents. Each document has data. There, imagine it to be a social media application. So it has another posts collection, it has another messages collection. So who gets to read what will be defined in rule-based access. So Firestore, one, you have your database, and there's another tab that says security rules. You can actually write those rules over there. Who can create a document in this collection? Who can read a document in this collection? Who can update it? And so on and so forth. Now, there's different ways in which this gets updated, your data. When you're launching new features, you inherently may make changes to your database and database models. So these security rules will have to be updated every time this kind of a change happens in your application. You also need to ensure there are tests that always validate these security practices and concerns. Another thing is getting your user management system. Using an existing authentication system is always the way to go if you're creating a server by yourself. You There's an example I talk about in the next slide. I wouldn't prematurely discuss it, but please do use third-party services. If you're using Firebase, there's Firebase authentication, the most popular. You could also use Superbase Auth. There are other third-party services that let you use different sign-in, sign-on methods. So that's about implementing reliable authentication protocols. This is when you're developing something. Now comes the time to distribute it. So this is where signing certificates come into picture. Many beginners do not really know about signing certificates, and the step at which they usually get stuck. There's this popular step in our tech onboarding journey when a newcomer is running their application, and during the sign up stage when they try to sign in with Google, there's an error that gets thrown. It gets thrown because of the signing certificates and the fingerprint with which they've built the app, and it not being recognizable. So what are signing certificates? Imagine you've ordered a burger from McDonald's, Burger King, Zomato, some place that you usually order food from. When it arrives at your place, the kitchen or the place that you're ordering from, think of them as the developer. They are someone who created something that you want, and they are packaging it together in a container for it to be distributed to you through a third party service, which would be your food delivery partner, the person who came to your place to give it to you, and different people in the chain. These different people in the chain are equivalent to your app distribution marketplaces like Google Play Store, Apple App Store. You may be using different internal systems to conduct your internal testing, while these two have their own internal testing tags, test flight and close testing, open testing. There's also Firebase distribution that you can use. You can drag and drop APIs and invite people by email, and they'll just get an email, hey, someone's invited you to test an APK with some instructions on email. And that is how you can test your next application. And just ping 10 of your friends on their email addresses through Firebase distribution. And so that's about distribution, but signing certificates play a role over here. What I was talking is when you receive that parcel, there's usually a sticker on it which says, do not accept if the seal is broken. What happens is when the restaurant has packed your food, they are putting a tape to tell you or to signal that it is them who have packaged it. And if it was tampered in the meanwhile, it's either going to have a different tape or this tape is going to be tampered. Same thing with a bottle of water that you would buy outside. If it's not sealed, you know someone has already opened it. You would not trust it. That's the same thing that happens. Imagine a large team. Why does every newcomer in my team get stuck at the authentication step? Because my authentication server does not recognize the signing certificate with which the application was signed. These signing certificates are unique certificates. They are either stored on the server. Think of it as a unique fingerprint. So, because the biometric did not match, it's not going to accept, it's not going to let you through your authentication step. So, tomorrow, if your code base was compromised and someone was to generate another APK or an IPA for it and distribute it to other users, your internal authentication servers and databases and distribution platforms will not accept it because it was not signed with something that you have agreed to. These security keys are something you will have to store on your device, and in today's age we use automatic signing. And on the iOS side, there's certificates that you create, versioning, code versioning, and profiles that you have for your team. On the Android side, there's app signing that happens through cloud that we are using right now. Now, moving on, key security practices, you need to avoid some pitfalls. What I was referring to in the earlier slide, a very naive mistake that a beginner could make is creating their own authentication system and trying to store all of the passwords inside a table. And that would be disastrous. You need to ensure everything that you're transferring during transit through your client and server, it's encrypted. So these are best practices for handling sensitive information. There are also concepts of tokenization. When you're processing payments, you need to generate orders and process it on the server side. You need to comply with different regulations like GDPR or HIPAA. These are some guidelines for treating user data with care and not having any legal implications or troubles relating to it. Now we move on to the next pillar in our reliability, crashes and crash logging. So, no matter what you do, crashes are going to happen. They are inevitable. They are something that you would not expect, and they will come at a time when you're overburdened with all of the tasks of the week. And you will just have to solve that issue because there's thousands of users who are facing it. Even if you've taken into consideration the controlled rollouts we spoke about, crashes will happen. What do you do when a crash happens, the first thing, one way of realizing it is someone leaves you a bad review. Hey, this app is crashing. But ideally, as a developer, you would want a dashboard that you constantly monitor, and there's some active reporting that if a threshold is crossed, if particular number of crashes happen, there's an email that gets sent to you. As someone who has launched different features every week, every month, it was a constant practice to monitor different dashboards after we have hit submit on the Play Stores. We always had to ensure nothing was crashing for first 10% of our users, then 100% of our users. And it's something that you have to take into consideration when you're developing different software, different features and functionalities. The difference between reliable and failing app often lies between how quickly you can address that issue, how quickly you can identify the crash, and how quickly can you get your user to a place where they were before. This is something you would realize in your monitoring dashboards, in your the simplest way of incorporating crash logging is Crashalytics. So once you notice a crash, you take action on it. So how does it work? When an app crashes, it captures some type of error. It will tell you what kind of a crash it was, whether it was a database error, null. Usually it's a null pointer exception. So if anyone ever sees something with a gray screen, there was some operation that happened on null. It was a common go-to statement in our debugging practices at workplace. So it always saves you time. You don't have to go to different places to figure out what's wrong. Then there's a stack trace of what's gone wrong. It's going to tell you line by line where you need to go look into your code base at runtime for different issues that you're facing. There's also device information like operating system, battery level, device model, app version that gets logged in your crashes. There are sometimes cases where some crashes happen only on certain types of operating systems or certain models of a particular brand, and we've been in those positions and places, and having this data has been really useful. We have been able to look at it, pinpoint it, verify it, create a new data point for the crash, replicate the crash, and come to a conclusion that it's only a particular edge case. And this was one example of pinpointing using crash logs. But on a general basis, you definitely need a strong reporting system for your crashes. When you're developing, you have your terminal and your console open. There's red lines every time there's an issue. You can solve it locally. But to solve it when your app is in production for different app versions, different integrations, it really helps having a third party integration take care of that for you. You actively have to error handle your code. When you're writing it, you have to break it down into different layers such that it is also debuggable and also loggable. And that's how you make use of crash logs. You identify problems quickly, you can prioritize problems based on what's happening, and you keep continuously improving your product. Next, we move on to debugging. It is the art of finding and fixing issues efficiently. This happens in two different phases: when you're developing as well as when you're in production. Crashes can be isolated, and debugging tools can save you countless hours when you're making and shipping code. So, there are some Flutter specific debugging tools that you can use during your development time. And these are also some tools that you will come back to when you have identified some crashes. So, there's two parts to it. One is a system that actually logs your crashes and gives you all of the stack traces and data. And the other place is debugging tools, your system that helps you make use of these crash logs and data, an environment that lets you reproduce that issue and lets you actively solve it through different tooling software. So there are built-in dev tools in Flutter where you can inspect your widget for layout issues. There's a widget tree viewer. You can monitor performance for your application if there's some frame rate drops, some issues that you see. There's hot reload and restart that quickly lets you update your application to check out the changes that you've done. Error reports and logs in Flutter, thankfully, have been a savior. They are very self-descriptive. They are proactive when pointing towards a solution that is not something that you see in a lot of frameworks and ecosystems. So anytime there's a crash, if you have a hard time solving it, I feel you need to reread whatever's thrown on the console, the error message. Usually there's a solution that is to be followed and it will take you to the place that you want to be. And then there's also third-party debugging tools that you can use to monitor the performance of your application. The best practices for debugging would be layered architecture, single responsibility principle, and error logging integration. So, layered architecture is dividing your app into logical layers. What this means is your logic is not on the UI, your data is not on the UI. UI does UI stuff. There's a different class for handling your data and business logic. And there's a separate part for all of the services and functionalities and utilities that you have. So, whenever there's an error that occurs in your technical system, it will be in one layer of your architecture. It can either be on the UI side, it can be on the business logic side, or it could be on the data access side. This helps you isolate and identify and also helps you handle those errors correctly. If you're fetching data, modifying it, and displaying it in a single file, one of the operation goes wrong, all three of them are probably going to break. So layered architecture helps you isolate your logic into different layers, and if an error occurs, it also gets isolated in those layers, and pinpointing it becomes easier. Moving on to the next best practice, single responsibility principle. Using different classes and modules to handle different logic, not creating a single object that does everything for you. So, by applying single responsibility principle, what's happening underneath is everything's getting a specific name, everything's being put into separate boxes, and if one thing fails, only one thing fails. It's not causing a failure for your entire system. So layered architecture and single responsibility principle together work hand in hand, and error logging and integration needs to happen on each step. Every layer has a different type of error that can surface. On UI, there might be some sizing constraints, some layout constraints that need to be managed. Some on the business logic side, there might be some edge cases that might appear that you need to handle. On the data side, there could be some network issues when fetching the data. So whatever issue happens, it occurs in a different layer. Each layer has its own area or playground to handle that error in the best way possible for their single responsibility. And if they cannot handle it, they just pass it on to the layer above or below, depending on how the calls are happening internally. Next, we are going to move on to a topic that I really love, feature flags. These are versatile toggles and tools to manage functionality in your application. So up till now, we have learned how we can version our code base. We can release different versions through the Play Store in a controlled fashion. We also learned how to incorporate crash logs and different debugging tools. Now, when we are launching different functionalities, it is important that you're able to resolve it from the server. Let's assume this scenario. We realize through our Crashalytics dashboard that our app is crashing since yesterday, or yesterday is a bad timing since half an hour. For the past hour, the app is crashing. So, what do? We go to our Crashalytics dashboard, we check out the cause for the crash, we see how many people are affected, we check out the stack trace, we go to our debugging tools, we figure out what the solution is. Now we realize that the solution is to release a new app version. Now that is a problem because releasing a new app version takes time and the users actively need to upgrade their application. A funny statistic, every time you create a new release, the adoption rate for that new release keeps going down. So if you're doing weekly releases, you need to know that your user base, not all of them are going to be on the latest application. Like I was mentioning, there are 4 app versions live at a single time in on people's devices. It may not be there on the Play Store, but you have released version 3.0, but the user is still stuck on version 2.0 because they refuse to upgrade it. So what do you do? Wouldn't it be really nice that we just click on a toggle on our dashboard and the functionality just disappears from the user's device? That would be lovely, and that is what feature flags are. They are server side toggles that will give you fine grained control over the features without requiring the redeployment. Now, feature flags do require an initial setup, but once you have them, you will be able to just switch features on and off from the server based on your requirements. If something goes wrong, you switch it off. You can also use feature flags to do controlled rollouts where a particular feature is hidden behind a flag. It is only visible to 10% of the users, and then it's gradually visible to 100% of the users. So, coming back to feature flags, what are they? They are server side toggles that control the entry points of specific features inside your app. They allow you to enable or disable certain functionality of your application remotely. You don't have to distribute new code for that to be visible. Usually, when you're developing, you would want to hard code it, but this is from the server side. How does this work? The app that you're distributing your that's on your user's phone, that is going to query a server. That server is going to have configuration and answer to yes or no. What is a feature flag? It's usually a question. Should I show this feature? Show feature A, yes or no. That is what the question your client application is going to ask to your server. If the answer is yes, you show that particular widget and related functionality. Otherwise, you don't show it. That is the basic implementation of a feature flag. How would you go about implementing them? There's Firebase remote config, AWS app config. If you want to go a little intermediate level, you can go to Split IO. That is something we have used at iMums before. It has allowed us to flag our features and also conduct A/B testing. There's Flagsmith, which is an open source version that allows you to launch your own feature flags and host it on your own server. So, feature flags, it's basically a tool that allows you to update app behavior and appearance without deploying new code. How do you use feature flags to test your hypothesis? Feature flags are perfect for testing hypotheses like I was talking earlier about app versions and code versions. Without full-scale deployment during controlled rollouts, your feature can be rolled out in control using a feature flag. When you're using remote config, the basic version, you won't get a percentage distribution, but the split feature flag functionality that I was using at imums, it allowed us on the server side to actually distribute our answer in percentages. We could say yes and no to that feature flag query in percentages. So 20% of our users were seeing the feature, 80% of them were not. And later on, they were gradually incremented after we monitored the real world data. How does this take place in real life? The feature flag is up in place. We go to our analytics dashboard. We look for a particular event that we know we are tracking called as feature flag evaluated. For everyone with yes and no, we create two different funnels. We then proceed to test the metrics that we were hypothesizing. Sales are going to go up, or there's going to be more button clicks. That is what you go and check. So, with your change, did it actually live up to what you had guessed? If yes, then you can use controlled rollout techniques along with feature flags to validate your hypothesis and roll it out to everyone. You get to gather real world data. You reduce your risk by limiting the rollout to a certain percentage. And feature flags let you iterate quickly to check out your user behavior. You could technically have 5 different versions of a particular feature that you create at a time and launch it with a feature update on the marketplace. And then for a month, without launching any app update, you can just toggle the feature flags from your dashboard and look at different type of data. So without an app update, you're still able to change what the user is seeing. That is what feature flags are going to help you do. Now, when we are talking about feature flags, there inherently is a separation between client side and server side. So we are moving on to server side logic, and it is something of an advanced concept. Once you get the hang of what feature flags are and why feature flags are used, you would ask the next question: why are we handling other parts of the logic after the feature flag question? Whatever's happening, it's on the client side. Why not do it on the server side itself and let the client app just be a client app? Let it not have anything. And that is one of the ways many businesses operate. And it was one of the systems that we had also pioneered at imums, and it really helped us iterate fast, ship fast, and it also helped us deliver really fast because everything was on the server. And essentially, after a point, what the application was, it was just monthly maintenance and upgrades. There was all of the new feature functionality was being served from the server, because after 4 years we had done everything that could have been done from an integration perspective, the basic integrations. But every logic change, we moved from client side updates to server side updates, which let us iterate really quickly and move very quickly in the market. What does it mean? All of your computations and logic, they move away from your client side and they are computed on the server side. Now, you usually write code in Dart, your Flutter code, all of your widgets, they're Dart files, and your logic, business logic on the client side is also in Dart. When you're moving to the server side, you have the option of still sticking to Dart and having your server architecture in Dart, or you could move to a different language and take support of cloud functions and TypeScript to get this working, get this serverless server logic going on. So the challenges of client-side logic, like I discussed earlier, the code is dependent on your app updates, and there's a lot of rigidity that is observed in your code. On the app update side, whatever logic that you want to deploy, it is inherently supposed to be distributed, which takes more time to reach your users' hands. And ultimately, it's going to take more time to get the numbers in your analytics dashboard moving. So that is when you want to decrease the dependency of your business logic on app updates, and shifting it to the server allows you to deploy those changes in real time. And that is going to be really helpful. So imagine this scenario that there's a banner on your home screen. Your product manager or your tech leader is coming to you and giving you this task to add a banner on the home screen. You would usually hard code the logic, but when comes the time to actually change some data for it, or actually change the entire logic for when the banner is going to be visible, is something that can be addressed up to this point using feature flags. But what if I don't want to show a banner? What if I want to show a list of cards? Then probably you will have to release a new app update if you are using client side logic. If you are using server side logic, it's just about supplying a different data to your client app, and your client app being smart enough to process that data and show a different UI element in front of you. So the rigidity in code is also addressed over here. Your client apps will have some logic hard coded to them. And once it's deployed, it becomes difficult to keep track of different versions that might be live at the same time. So moving from client side to the server side allows you to forget about all of those differences, because they at a point cease to exist. There's always a source of truth that is served through the server, and it's always real time. So no matter what different app version someone's using, they're probably going to see the same thing in front of them, more or less. There could be some cosmetic updates that you have. So server side logic is what server side logic is. It's coming to your rescue. It's going to give you dynamic updates. It's going to help you with scalability. It also is going to help you with consistency across platforms. And there's also a centralized control with server side logic. Your client app basically is just a UI display node. It just knows how all of the cards in your universe look, how all of the buttons in your universe look, all of the actions in your universe look, all of the pages that you might have, different types of UI elements. Getting all of your design system elements being addressable through the server is the first step. And then you just start injecting your business logic, controlling it from the server side. This is also helpful to power remote config and A/B testing. When you're doing something like this, your server essentially is the node that is doing your A/B testing or feature flagging. But at the same time, you're going to have to use another third party service or your own custom solution to manage additional logic. But it still stays in the server. The client app is only supposed to pull configurations from the servers, what's supposed to be visible, what's supposed to not be visible. Whatever's visible, what data needs to be visible is also supplied by the server. And what would A/B testing be? Is this version better or is this version better? So hypothesis validation ultimately refers to A/B testing, where you have multiple variants of something that you want to test and you monitor. Now, another example I could give you is a music streaming app that dynamically delivers curated playlists. Your Spotify Wrapped is something that was delivered to you dynamically. You never had to update your application to actually be able to see that banner over there. So, the way it was done is probably 3 months or 4 months ago, every UI element that was required to process this particular feature was shipped and it was behind a feature flag and it was not visible to the users. And there's also some server side logic at play. So as soon as the team decided that we are gonna launch our Spotify app, they just turned the feature toggle on their feature flag dashboard, show Spotify wrapped is equal to true. And now your client side application is gonna go to the server because of that feature flag. The server is gonna give it all of the data that needs to be displayed. And because the client app already has all of the logic or all of the code it needs to know to display that data because it came 3 months ago, it directly shows you whatever. So even without launching an app update, if you have planned sufficiently ahead about what you want to launch, you can launch it once and keep playing from the server side. So when you're building cross-platform applications, a single code base is going to sound ideal, but it's not practical. When you start out with your Flutter application, it is a single code base, a single repository. But as you start adding these frameworks, as you start adding new features and functionalities, it stops being a single source of truth and your data is going to be distributed in different places. There are going to be different dashboards that have different values. There is an active version of your server that is deployed, and there's also cross platform specificities that come into picture. Your Android and iOS code is going to diverge at a point because platform specific requirements. There are considerations you have to take when you're developing cross platform, be it Android, iOS, web. You have to consider how different functionalities and features behave on these platforms and what these platforms and operating systems require from you as a developer to serve your users. A simple example would be about push notifications. On Android, you can just use Firebase Cloud Messaging. It's a token that you generate on your client side. You put it on your server, and then your server can start sending push notifications to the Android application. Even when it is in the background, you will still receive those pings. But when you want to incorporate push notifications on iOS side, you have to register yourself through the Apple push notification service. And that service is something that acts as a middleman, a middle barrier. So even if you keep sending push notifications, your Apple push notification system may throttle it based on their own code base. So that is a platform specific requirement that you have to comply to. You also have permissions that play a major role. Different operating systems and different platforms, they have different ways in which they process data and they have different APIs that you have to cater to. The consideration here is to have your fallback logic in place where a particular action may not happen as expected. So you have to write logic that takes care of it. The best practices to manage these differences is to abstract out your platform specific code. An example for notifications would be using libraries like Flutter local notifications, where it's only letting you use a particular layer of abstraction or API to address notifications in your universe, but under the hood, it has platform specific behavior. Anytime you're incorporating or integrating a package from PubDev, there would be some platform specific integrations that you have. So that is what abstract platform specific code is about. You have to make those tweaks on your native platform side. Then you also can conditionally handle features when you are doing it by yourself. Say you need two different packages to handle the same thing on two different devices. So in Flutter, you have platform is Android, platform is iOS. You can use these to conditionally switch between what you're doing or what you're displaying on different devices. After this is done in your development, you have to be thorough in your testing because the underlying workings are different on different platforms. You have to test the same thing on both the devices. Every time you create a new update, you have an Android testing build, you have an iOS testing build, and you test the same thing on both of the devices to ensure it works. That is what will happen in production, and that is what one must do to ensure your app is reliable. There are different automations and practices and different tests that you put into picture, but manual testing for the win. Thorough testing. After that, you have to respect the native guidelines for each platform. Google has their material guidelines, Apple has their human interface guidelines. So these more or less outline how these platforms want you as a developer to design and develop and distribute to users of these ecosystems. And it is really helpful to get third party approvals when you're launching on these play stores to comply with these specifications. Every platform comes with their unique native features that developers must leverage. What we spoke about is earlier on differences and how to handle them, but now the differences are supposed to be treated as unique. There's different GPS, there's different things you can use, such as GPS, health kits, accelerometers, your cameras. Using platform specific functionality and native capabilities for your application is really important. You cannot just use plain code for yourself. And there seems to be some screen sharing issue, but I will still continue. Your platform specific capabilities allow you to go beyond generic functionalities of your application. Your code cannot simply rely on only Flutter specific widgets. You would inevitably come at a point where you have to use the camera, the speaker, the microphone, something or the other to make your app better, to give your user a better experience. Native features align with the user's expectations. It's a natural extension of the platform. One example I would like to give you is at iMums, we were developing a digital program, and in the health and yoga section, we had a dashboard that allowed users to visualize their yoga minutes. Now, since we were building this health feature and functionality, we decided to also take help of Health Kit that was available on iOS devices. Your platform is by default recording some step counters, run counters, how many calories the user has burned. What we did is we just integrated and leveraged the platform specific functionality. We pulled that data in from the user's device, the native device, and just presented it in our application. That is how we leveraged what was already available. On iOS, we had some two or three data points that we could query. On the Android side, we only had one step data that we were querying, but it was added value in the user's expectations and their day-to-day life. We did not have to do any manual data entry. It was just a sync. We just had to get the user's permission once, and it kept on working every day. The steps would update on their own. So it's just added value in your user's life through innovative ideas and things that already exist. Other native capabilities I would urge one to explore are location services, camera and media access, push notifications. The platform specific APIs would be Play Install Referrer API, Google Fit. On iOS, you could try ARKit for augmented reality, Core Motion to actually detect how the user is moving. With smartwatches and health devices, you could sync your health device with your phone app and do anything with the data as you please. The best practices here would again be abstracting the native features into your Dart layer. These native features exist on very OS specific or platform specific level. And if you're building cross platform apps, you need to start pulling them ऊपर के layers में on Dart side. You must respect permissions given by the users available on the platform. And it is important to optimize for battery usage when you're using these native functionalities and hardware sensors because they come with a significant battery usage and it can leave a bad impression, bad taste in your user's mouth. You don't want a bad app review for no reason. So these were all of the different individual dissections of frameworks that I've put in together. We are towards the conclusion part of our slide so presentation. So I would conclude by saying reliable structures need a strong foundation, and those strong foundations require investment for your building to stand tall and not fall when there's a storm. You must have invested at least a little more when you were building it from scratch. So your foundation needs to have all of these hidden frameworks in place to create that backbone to be reliable. And it just isn't about code, it's about the commitment you're making to your team, to your users, to the business, to yourself. Whether you're testing the new features, you're ensuring compatibility, or integrating these native capabilities, every decision you make shapes the trust the users are going to place in your app. And when you're using it in production, these are the inherent risks you sign up for. So you have to make these promises. You have to ensure that you make things reliable. And in conclusion, I would ask you, as you're building your next project, what hidden frameworks can you put in place to make the app more reliable? And that's it. That's about it. I would like to quickly recap all of the features and frameworks that we went through. And if there's any question and answers, I would urge others to put them in. And that's about it. I hope everyone enjoyed the talk. The reliable frameworks that we have is code versioning, controlled rollouts, security protocols, crash logs, debugging tools, feature flags, server side logic, platform specific requirements, and native capabilities. That's it. I hope everyone enjoyed the talk and I am open to question and answers. You can drop them in the chat box or you can send me a direct message on LinkedIn. The live stream has all of my social media accounts linked below. And it was a fun conversation, I would say one way.
Awesome. So we do have a question. I'll just take that up.
Yes.
So Ayush is like how to make sure that after pushing a new update, the audience will update app to the new version, as my previous version users may get affected due to the new updates from the backend. So I'll give an answer that I use, and then you may suggest an alternative something. So
Sure.
as a Sasta Jugaad, what we do is we have created a parameter in our Firestore which says the version or the latest forced version that we want. Along with that, we have created another parameter that is must update or not, true false.
Mm-hmm.
And so whenever a user opens the app, they first check the application checks these two values from the Firestore. And if the current version of the user does not match the new update, it shows them the update screen. And on the update screen, we have two buttons, primary and secondary. Primary button is redirecting them to the store, and the secondary is skip. Skip is shown based on mandatory update or not.
Hmm.
But this is a worst solution possible. Being a user, I would not update my application every other day. So, yes, alternative.
Well, the solution you have mentioned is one of the natural solutions we go towards. So, going back to the hidden frameworks that we have, what Laksh mentioned is adding a feature flag and also some server controlled logic where you make your decision based on the fact key what's the latest version that you want to allow, or what's the minimum app version that can be out there. And your client side code is always going to query that, compare its own version with it, and if it fails, there is something you will there's something like said, it's the worst thing you could do, because if you're going to do it on a weekly basis, then that's very frustrating to the user. But as a hidden reliable framework, it really needs to be there when the time need be. So at imums we always had this, but we never used the first update functionality because we did not want our users to have that experience. We were okay with just letting it slide by for some users and proactive communication. And thankfully, we were never in a situation where things got so bad that we had to force update something. But server side logic and feature flags
Feature.
to actually create this app update logic or app update functionality is the way to go, Ayush.
Awesome. So, Ayush, if you have any other questions, you may ask. Until then, I'll continue with a few questions that I have. So, in the start, you
Yes.
mentioned about dependencies that you had to face at IMMs during the null change in
Yes.
Flutter. So I get this question a lot in the community from folks that if I have a package, why do I write that code? I can depend on the package, right? So for
Mhm.
example, the basic thing is a pop button. If you know pop button by Cred, there's a package
Mhm.
for that. But the same
Yeah.
thing can be done with a few animations in Flutter. So the thing is, you explained it that don't be dependent on dependencies. Be dependent on them if they are a huge thing, or else just code it, have it with yourself. No more dependencies, no more crashes.
Correct. And if there's a maintainer, package maintainer that you believe is always going to keep that package updated, by all means, take help of that dependency. But like you are also mentioning right now, it's about picking and choosing what should be a dependency and what should not be a dependency. Your loaders and buttons and mini visual elements not necessarily need to be a dependency. You could always refer what's out there. They may have been published as a package, and they may be suggesting you to use them as a dependency, but it may be bloated, or you may just need one small part from it while importing 10 different files that increases your app size. So it's a it's a decision you have to take, whether you're willing to maintain somebody else's code, or is it worth just depending on them to take that effort. Most
Understood.
of the
Nice point.
packages definitely do have support. So if you're using Firebase and Firestore, anything that's Firebase related, it's always in sync with your Flutter updates. Every time you have a framework update, these core packages are also being released with compatible with the latest version. So always depend on the most popular packages. Do check the scores that are displayed, the frequency of updates, who's publishing those packages, if they are maintained by someone in the team or someone just who's casually uploaded it as a project. So that's how you can be less dependent on dependencies.
Understood. I have a question on this. You mentioned that you forked the dependencies that were used at iMums into the organization, and then you converted those dependencies to be null safe to support null safety, and then you use the repository link. Why didn't you just
Correct.
create a PR on the dependency so that others could use it?
Well, the reason why I actually had to fork that dependency in the first place was because the package author or the person maintaining that package was no longer active on that repository. So I could have taken the route of just creating an issue on the GitHub link, requesting the developer to update his code such that I get the latest version, or my forked version, I just create a pull request with the original version, and then there would come another step where the author has to accept that solution and also publish it out there. So we were in a position where some of the package authors had abandoned those packages and
Okay.
we were in need of some packages. It was also a time when we moved away from some packages. We realized that in the initial days it was really easy relying on third party code, but as our code base is growing, the dependency issue could grow multifold as the apps and requirements grow. So wherever possible, we try to cut down our dependence on external code.
Understood. Okay. So we have another question by Manav. Hey Bhaiya, how to optimize a Flutter app to avoid UI junk during complex animations or heavy data handling?
Correct. So there are two, three approaches I can suggest over here. Complex animations, I would suggest you to optimize all of the calculations and try to solve it from a mathematical perspective. Ensure that you're not performing too many calculations. It needs to be efficient in terms of space and time. So it takes you back to some DSA basics. And about heavy data handling, you can always rely on processing it on the server side. And if you can't process it on the server side, there's always an option to resort to isolates or moving to a different. There's no different thread as such, but you could call it a different thread where it launches the computation in a separate environment and the UI computation stays smooth. And once the data is handled, it's just passing it back to your main application. Look into isolates, Dart isolates, Manav.
Yes. A new release recently that they announced about isolates, I suppose. I was going through that and I used it with Custom Painter in one of the applications that we built. It works smooth. You can try that. And then going next, yes. So you mentioned about rollouts, controlled rollouts, right? What if I was supposed to just push a bundle into the store directly? Can I control my rollouts then?
Yes, your controlled rollouts, you do have an option on the Google Play Store and App Store side of things. So the way you would go about releasing your application is the very first time you do it, you create a listing first. You add all of your information. This is the name, this is my data policy, this is my privacy policy. These are some things that I'm collecting. Then you drag and drop, attach the actual APK or the bundle that you want to distribute to that listing. Then that becomes a submission for your application that you submit and get approved from the Play Store or the App Store. Now, once that is approved, that's the first version that you have. But now comes the question, does it have to go live immediately or what do you want to do with it? The marketplace has approved it. They are saying, okay, you can sell it now or you can distribute it, but do you want to do it right away? They're going to give you two or three options. Yes, after you've approved it, directly start showing it to the audience. Otherwise, you approve it, but I will tell you to what percentage of audience you need to release it. The percentage part can be controlled on the Android side. Android uh, Play Store Play Console dashboard allows you to control the rollout in terms of percentages. You can do it from 10 to 100, however you please. But on the iOS side of things, you cannot control it granularly. You can select an option that says, I want to release this over a period of 1 week. And that's the only option you have. So instead of immediately sending it out to everyone, 20% on day one, 20% on day two, throughout the week, Apple themselves will take care of rolling it out in phases for you. So there's some control you lose on iOS side, where on the Android side you get that granular control. So if your feature flag system is more advanced, you can keep maintaining that granular control from your server side. You let that app update immediately pass through and not use the phased version. And that phasing part, rolling it out in phases, can be controlled from your server or your feature flag. So there's
Understood.
two, three
Okay.
different ways you can go about it based on the complexity level you're at.
Understood. Okay. So you mentioned about the percentages, right? In this, as well as for feature flags using the server side logic. You mentioned that you would use 20% initially, get the update, they test it based on their performance and hypothesis, you would roll out to the 100%. So this
Correct.
20% or X percent, can you handle what X person should get it? Like whether I should get it or not, or that's totally randomized.
Well, there's two ways of doing it. If you want to randomize it, you can randomize it. And if you want to specifically target based on some attributes, you will get that get that functionality in advanced type of feature flagging. If you are using remote config, it's only client queries the server and server gives an answer. What you want to do right now, what your question is asking is, client goes to the server with some attributes and information saying, hey, I have these things at my runtime. I am this. I am an Android phone. I'm on this operating version. I have this much data connection. I have these user attributes. You go to the server. Now, your server, where your advanced feature flag system resides, that is where you can set up logic based on these attributes. If this person is a paid subscriber, show them this banner. If they are not a paid subscriber, show them another banner. Or if this person is someone who uses my app frequently, don't show them this advertisement. But if this person hasn't been using the app on a frequent basis, start targeting them with certain features to help them understand either your app or make them retain on your application.
Understood. So it's basically the play of your server logic,
Correct.
where you handle the proper niche, subscriber or non-subscriber, that way. Understood. Okay.
Correct.
Now this next doubt or the question that I have is, you mentioned about the crashes and crashlytic integration into your application so that you get a proper dashboard of what's breaking, what's not breaking. Now
Mhm.
that's based on the try catch or the logs that you have imprinted into your code,
Mhm.
right? What if it's something else? For example, a UI breakage or overflow, but the user can see the text flow out of the box.
Mhm.
First situation. Second situation, I'm using a YouTube player and the link that I'm getting from the backend is not a valid YouTube link.
Mhm.
So the player is not recognizing the link and that's breaking. So I don't think so that gets logged into Crashlytics. So how do we handle these two or these type of logs or errors?
Correct. So first thing I would address is I would ask you to recollect is the layered architecture that we spoke about. So breaking down your code into different classes and different layers that have individual responsibilities would be helpful. Every layer will have different set of errors. So in our layered architecture, the error where the link is actually invalid is something that can be handled in the business logic layer or the data layer itself. You may not let it pass to your UI layer. Imagine a single code base file that has a video player widget and a future method in it that just fetches your video URL from the server. Now, if that URL is failing, everything in that file is going to fail. You may not have set up your try catches in the right places, or things might be failing outside of your try catches. So, if you have layered architecture, you get specific places where you can put your try catches, because your data is by default going to flow through different layers. You've decided that इसके बाद ये layer आएगा, इसके बाद ये layer आएगा, so there's no confusion. And then about unhandled exceptions, UI layer wale exceptions, I would suggest writing some tests beforehand using some physical devices to actually check. With the latest version of Flutter, I actually haven't used that particular functionality, but I have seen people talk about it on the internet. You have uh, a new view where you can check out your code base in real time on different devices, how it's going to look. So there's different screen sizes that you have in front of you. Your layout issues are something you can catch at the development time itself, instead of hoping for them to be a problem at your runtime. And rahi baat about catching uncaught exceptions, what you could do in your main file around your run app and those methods, you wrap it in a different method and you catch all uncaught exceptions. So internally, different layers have granular crash logging where galat data आया तो you manually log a crash saying there's a there's an invalid URL that was fetched from the database. So you stop at the database layer, and your UI layer or business layer is by default not going to flunk, and it's gonna get a message saying there was an error in a different layer. So you are not gonna get data. You display an error widget instead of actually flaking out and crashing the application with the faulty data.
Understood. Okay. So one thing you mentioned about the widget preview that you saw, the seeing the code in various sizes in the Flutter preview itself.
Correct.
Yeah. So that's still in the beta phase. It's going to come. Like that was a proposed solution in
Mhm.
the recent announcement. So yeah. And secondly, about the thing that you mentioned of in the void main before the run app, we do have a provision for flutter dot on error. So any error exception that is not handled and it occurs, you can create whatever you want to showcase there. So
Correct.
these are the
So
two things,
your
yes.
Crashlytics logging whatever code that you're using in
Huh.
your other catch blocks is what you would put in your flutter.onError method as a callback. You
Yes.
would register it before your app runs.
Yes. Okay. So in this answer, you mentioned about the layered structure, whereas you even mentioned in your talk. So in the layered structure, you mentioned about the data layer, business logic layer, and then comes the presentation layer, the basic layout. Okay.
Correct.
Which state management would you suggest? Most asked question in the community. Which state management would you suggest that we use so that our application follows this structure or follows the best principles?
So this has always been an opinionated answer in the community. My personal preference is blocks. They have been reliable. Blocks and qubits is something I love to use. They are useful in most of the cases where we require state management solutions, and places where qubits and blocks don't work, we have change notifiers, a built-in solution that we use. So all in all, that is what I particularly rely on. There's no right or wrong way to do it. It's based on your personal preference and how it ties to the other architectural decisions that you have. But from my personal experience, the layered architecture blocks have been great.
Understood. Noted. And then, yeah, basic question. What's important? Spending time to engineer a solution or developing a working application in a week?
Hmm. I think we have to balance out between the both because I have been in both the situations where I have wished that इसके बारे में और सोच लिया होता if only I would have had more time to think this through. And I've also been in situations where I haven't got anything done, and I was like, I spent every hour that I had chalking out all of the edge cases and making something pretty. So I would suggest getting the prototype out is something that is very necessary in the business world when working on projects or collaborating with cross functional co-workers. It is important to share the same vision. If you're only strictly working with the tech team, you are at the liberty of getting a week to think about tech. But if you're talking to people who are not doing tech, getting something out as soon as possible is what is suggested.
Understood. So it depends upon the situation that you are in or environment you are in. Based on that, you need to make a decision of what to do, what not to do.
Correct. I mean, I have worked in two, three different organizational scenarios where I was a part of a tech team, and tech team only spoke to the tech team, and any requirements or tasks or anything that was to happen. Tech team used to talk to tech team, and the tech leader, the CTO, was the person who was communicating with the other remaining part of the organization. So it was all shielded in a way where tech had their own box around. We were protected by our own tech bubble wala universe where we could spend weeks discussing technical problems. We were not directly responsible for answering business level questions. Someone else was doing it for us. But after the first 2 years, as I started to grow in terms of product sensibility and technical seniority, I started to realize I actually started collaborating directly with the design and product teams. It was the three of us, tech, design, and product, that kept working by themselves. And in that scenario, I could not afford to spend a week on creating a technical plan because the people that I was collaborating with were not technical folks. And even if they were appreciative of the fact that I am taking time to create the best technology, they were not gonna get anything out of it. They would have been bothered about, we spoke about a hypothesis last week. Are we able to test it today? It's been a week.
Mhm.
I don't know what happened, but I want some answers today. So getting that prototype out is important when you're working in a smaller team or you're moving fast. If you're part of a bigger structure, do give time to technical discussions if you have the right kind of team and mentors around.
Understood. Okay. So now my final question to you. You have mentioned all the hidden frameworks behind a reliable application, the nine pointers that you mentioned, right? I'm pretty sure
Yes.
you implemented all of these over a period of time at IMAMS. How
Yes, we have.
long did it take for you to implement it into a product?
So it definitely took us 4 years to get to a stage where all the nine frameworks were covered up. Particularly the server side logic is a robust framework and an extensive framework that can be incorporated. In the first year of IMUMS, we already had versioning under control. Controlled rollouts was something we were dabbling in. Crash logs and debugging is something we had to put in from the very first year. As years passed, our debugging techniques started improving. We started collecting more data as to how the app could fail, gathering data points. Like I said, in production, if some screen is gray, you must know that some method was called on a null object that was not supposed to be null. So if someone's complaining gray screen hai, you have to look for a null issue is what was popular. So by the second year, we had those things. We moved on to feature flags. We started with remote config initially. Then in the third year, we wanted to move away from remote config. So we decided to use split IO. And interesting fact, Split did not have a Flutter equivalent integration. They only had Android and iOS native
Natives.
SDKs that existed, and जैसे Razer पे use कर रहे थे, Firebase use कर रहे थे, we just had to go to PubDev and get code and integrate it. But when we decided to go the pro version for our feature flagging, we had to do it from scratch. So we found out about Split. We decided that it is the product integration that we want that's going to solve all of our problems. But the next challenge was actually getting that integration done. There was no official support. So if you go to the GitHub account for the organization IMUMS, there is a package that we have created on our own. We did an iOS side, Android side integration by ourselves, where, and we also published it on PubDev. So that was our small contribution to open source, where, and we also had people using our package. So that was something really fun. We learned a different skill set, how to create your own package. जो दूसरों का use कर रहे थे, आज हमने भी खुद का बना लिया. That's how Split was incorporated in our application. Then the server side logic was a really advanced concept that happened inside the organization. It was not the product's decision, it was not the design functions decision, it was purely a technical decision that was taken by senior leadership. They Shout out to Namita and Mayur from IMUMS, by the way, two senior developers who actually came up with the internal structure for server driven UI, a proprietary framework we were using at IMUMS. So these two folks recognized the fact that client driven code was a bottleneck for the organization. So they created a system, a server, and communication protocols that would let us talk from the server to our client application. And I've had the privilege to improve that system, add to that system, keep maintaining it for a year. So these were the 4 years of how these reliable frameworks gradually were introduced at IMUMS to make it the reliable app it is today. So we take pride in telling everyone that we have more than 4-star ratings on both of the Play Stores, and getting there really required putting our skin in the game to get all of these invisible frameworks in place.
That's amazing. Like 4 years journey, amazing. So nothing is done in a day or two, folks. It takes quite some time and quite some knowledge. So cheers. Also,
Yes,
another
Rome
thing that I
was
wanted
not built in a day.
exactly. Also, one thing that I want to mention, uh, Shreyas, you mentioned about the server logic, right? So by server logic, you mean server-driven UI for the clients.
Correct. Now, server-driven UI was specifically a solution that controlled the UI. This also includes processing some business logic on the server side, but even if you're not processing the UI elements on the server side, your logic could still be processed on the server side. A simple example I'd like to give is I'm building this new app called Mentoria Connect, which helps you find different mentors based on your challenges and your domains. Now, there are multiple database queries that are associated with the business logic. Arbitrarily, let's consider there are two queries. The first query is going to match your challenges that you're facing, and the second query is going to match your domain of expertise. I have some growth related problems at work. The first query will find all mentors from that. I am a software engineer. The second query will find everyone from the software department. Now, if this logic is on the client side and tomorrow I decide that I want to swap the order of these two, or maybe I want to add a third query, this business logic is actually on the client side. So, an equivalent for moving that logic to the server side would be having a Cloud Function API that requests just for the data. The UI is not changing. We are not modifying the UI anywhere. The UI still is going to be the same way that it's going to be. It's just that instead of the client talking to my database, my server is going to talk to my database, and the client is only asking for a list to be displayed in the UI instead of querying and creating that list on the client side. That is the main distinction we want to create when we say server driven logic or server side logic. It's being able to modify things on the server and having those changes reflect in your application.
Understood. So there's a difference between server-driven UI and server logic. Understood this.
UI would be the next step of processing that logic. Directly
Okay.
controlling the UI is a little bit tricky, but there are still packages available on PubDev again. I think Mirai is one way to supply direct Flutter widgets from the server. There are other structures. You can just JSONify your code, dynamically deliver it. A few ways to implement server side logic apart from remote config or cloud functions.
Understood. Understood. I hope you folks found this session really interesting and knowledgeable. I had a lot of fun talking to you and discussing. In case you want to connect with Shreyas, all his social links are mentioned in the description. Do connect with him. And I hope you're on the Connect Mentorial app so that they can connect with you there.
Yes, I will soon be launching the app, and you will be able to look me up on the app as well.
Perfect. Amazing.
Yes. Thank you everyone for being a great audience. Thank you, Laksh, for being a wonderful host and conducting the session in a wonderful way. Thank you for inviting me to Flutter Nagpur, and cheers to everyone who joined and everyone participating in the event.
Awesome. So, bye bye. Good night, folks.
Have a good night.